So let's look at the properties of inverse trig functions here, right? So we've talked about three inverse functions. The functions that we have talked about are sine inverse, cosine inverse, and tangent inverse. Okay, so first let's look at sine inverse of x. Or we also write that as arc sine. Okay, now on the exam you could use whichever notation you want. If you want to write this as arc sine or sine inverse, I'd be okay for both. Okay, so now let's look at a couple things here. And the first thing that I want to look at is the domain, which we already know. Okay, we're going to look at the range. And then we're going to look at the inverse function property. Okay, so sine inverse of x. What is the domain of sine inverse of x? Well, that was -1 to 1, and the range of that function was -π/2 to π/2, right? If you remember, if you look at the inverse function of sine inverse x, which is sine x, and we know that the sine x was restricted to -π/2 to π/2, that was the domain. So now this becomes the range for the inverse function, and the range of the sine function, which is -1 to 1, becomes the domain for this function. Okay. Now, inverse function properties, if you remember, there were two, right? We had f(f) inverse of x equals x, and f inverse of of x equals x, right? So that is, if we went ahead and if we combined our inverse function and the function, right, if we did a composition of those two, we will always result in x. Okay, what would that look in this case? So in this case, we have sine inverse. So we have two, sine inverse of sine of x is equal to x. Okay, whenever -π/2 less or equal to x less or equal to π/2. Okay, and the second one we have is sine of sine inverse of x is also equal to x when I have -1 less or equal to x less or equal to +1, right? So these are the two properties I have for sine of x. Let's go ahead and take a look at cosine of x. So the inverse of cosine we know is cosine inverse of x, or we also write that as arc cosine. Okay, and again, its domain is the same, which is -1 to 1. And if you remember, we restricted the cosine function to 0 to pi, which means the range for my cosine inverse has to be 0 to pi. Okay, and now I have two similar properties, and I have cosine inverse of cosine of x is equal to x, where 0 less than or equal to x less than or equal to pi. All right, and the second one is cosine of cosine inverse of x is also equal to x. Okay, and here -1 is less or equal to x less or equal to 1. All right, and finally, our last inverse function, which we're going to study, is tan inverse of x. So I have tan inverse of x, or as we call it, arc tan of x. Okay, if you remember, the domain for this one is going to be -∞ to infinity. Okay, its range is from -π/2 to π/2. Okay, and then our two properties are going to be tan inverse of tan x equals x, where -π/2 less than x less than π/2. Okay, and the second one we have is tan of tan inverse of x is also equal to x, where -∞ less than x less than infinity. Okay, so these are your basic properties of inverse functions. All right, so let's use the properties that we saw to solve certain problems, right? So what I want to do is I want to find the exact value of sine inverse of sine of negative pi over 9. Now the first thing we want to check here is we want to check that this is within, right? This is within negative pi over 2 and pi over 2. And we see that it is. So we know that negative pi over 2 is to the left of negative pi over 9 is to the left of pi over 2. Okay, so that condition is satisfied. So if you look at your property, the property said that sine inverse of sine of x equals x if negative pi over 2 less or equal to x less or equal to pi over 2. Okay, and so for that reason we have sine inverse of sine of negative pi over 9 is going to be equal to negative pi over 9. Okay. All right, second one. So here, right, I want to solve cosine inverse of cosine of 5 pi over 4, and we know this. We know that cosine inverse of cosine of x is x, right? The condition, however, is that 0 less than x less than pi, or less than or equal to x less than or equal to pi. Now, that's a problem for us right now because notice that 5 pi over 4 is not over there, right? 5 pi over 4 is actually greater than pi, okay? But if you remember, cosine is a periodic function, right? What does that mean is that it repeats every 2 pi. So I know one thing is that I know that cosine of 5 pi over 4 is also equal to cosine of 2 pi minus 5 pi over 4, right? Because the period of the cosine function is 2 pi. So if I take one more revolution, I'm going to end up at that point. And so cosine of 5 pi over 4, if you simplify this, you're going to get cosine of 3 pi over 4. Okay, so I know that cosine inverse of cosine of 5 pi over 4 is equal to cosine inverse of cosine of 3 pi over 4. And now I can see that 0 is less than or equal to 3 pi over 4, right? Because that is less than 1. 3/4 is less than 1. And so that is less than pi, okay? And so we get this is equal to 3 pi over 4, okay? So note that this formula or this identity only works if this angle here, the 5 pi over 4, or whatever that angle is going to be between 0 and pi. If it's not within this restricted domain of your cosine function or the sine function or the tan, if you're going to use tan, then this formula or this identity is not going to work.